Roto is a company building robotic vehicles for the inspection, maintenance and repair of offshore oil and gas structures and wind turbine towers. Together with Olympus Singapore, a leading manufacturer of test and measurement solutions used in aerospace and oil and gas, they signed a Memorandum of Understanding in April 2021 to cover collaboration in joint technology development in non-destructive testing (NDT) of pipelines. Olympus have global presence and have forged technology development over more than half a century. The key objective of this MOU was to be able to continuously perform C-scan mapping of pipes below sea level, up through the splash zone and above water. Roto have built a module to perform cleaning, close visual inspection and phased array mapping for the high-end inspection of steel pipes. When deployed by the Roto Climber, this cleans the pipe's surface to a finish of SA 2.5, then performs a close visual inspection which is recorded by high-quality 4K video cameras. Close-up still pictures of defects discovered can be taken. In this video, we can see the results of the phased array testing that was conducted in August this year using the Roto Climber Mark II cleaning, CVI and PA-UT module. This was performed under controlled conditions in a tank. The phased array inspection was undertaken on a specifically constructed piece of pipe with known and measurable defects placed in it. This was done so that the results obtained could be directly compared with the known defects in the pipe. Here you can see the results of the PA-UT mapping. This clearly shows the defects discovered and the results are easily stored for later evaluation if required. This mapping has an axial coverage per scan of 60 mm. The scan speed can be up to 100 mm per second. It took 1 minute to do 60 mm of axial length. Using the same cleaning CVI and PA-UT module but with dual probes, the axial coverage can be increased up to 120 mm. If dual probes were used and with a scan speed of 100 mm per second, then a phased array inspection could be performed on a pipe with 32 inches outside diameter at a rate of 4.5 seconds to perform a 120 mm axial length scan, or 4.8 minutes per meter of a 32-inch pipe. This is very much faster than other methods on the market. As an example, using the axial coverage per scan of 120 mm and a scanning speed of 100 mm per second, then a 140 meter rising could be mapped in 11.18 hours. This time excludes the time taken for the Roto Climber and the PA-UT module to climb over the riser clamps. Depending on the type of coating on the pipe, it may not be necessary to remove these in order to perform the C-scan mapping. Phased array equipment is commonly used to provide highly accurate information in ultrasonic testing of materials. This application is a new tool in the offshore industry. Olympus' range of phased array devices produce accurate, detailed cross-sectional pictures of internal structures at fast inspection speeds. These powerful tools allow precise data acquisition, visualization and analysis of ultrasonic signals. The phased array equipment and phased array software solutions are fully integrated, with fast calibration and streamlined user interface so you can complete your setup and inspection in minimal time. By using the Olympus Focus PX and the Hydroform buggy mounted inside the Roto Climber cleaning, CVI and PA-UT module, the pipe can be mapped from the surface, through the splash zone and down to the seabed. The Hydroform utilizes an ingenious water column concept that eliminates the need for a wedge, thus providing the benefits of a phased array immersion tank inspection. This gives optimized coupling on rough surfaces everywhere. Uniquely, the Roto Climber Mark II can walk down a riser and over the riser clamps, meaning the entire length of the riser can be mapped down to the seabed. The phased array data recorded can be integrated with the video and still photos taken by the module. The Focus PX acquisition unit and weld site software incorporate the latest phased array and conventional UT technologies for easy integration into automated and semi-automated systems. This inspection solution enables you to generate and save C-scan and A-scan raw data for applications where the verdict is based on post-inspection data analysis. The weld site inspection and analysis software is designed for use with the Focus PX phased array data acquisition instrument. For inspectors who use the Focus PX data acquisition unit to conduct phased array, WeldSight or OmniScan MX2 software helps optimize defect detection while reducing the amount of time required and, consequently, the overall costs. The software can improve the efficiency of engineering advanced phased array inspections by facilitating each step of the inspection workflow, from scan plan creation to reporting, while taking into consideration repeatability requirements, code compliance, and unique weld characteristics. This technology, married to the new ability to perform C-scan mapping from surface to seabed, enables the customer to have a record today of the state of their pipe and to be able to replicate the mapping later to closely monitor the rate of degradation, if any, of their asset. Following on from this is the potential of the customer to initiate remedial action. This could be additives in the product or coating the pipe exterior. These techniques are not confined to the fossil fuel industry, but also the renewable sector, where wind towers and their foundations also need to be inspected. We're confident that these results will change the way that inspections are performed offshore on risers, conductors and caissons, and that other applications will soon follow, now that Roto have led the way.